Heyo, this is 6.7. So determine how many solutions or zeros a polynomial will have. Remember, that's the leading or highest degree that you see. So for number 1, there is 4 solutions. The number 4, because that's the highest degree. For number 2, there are 3 solutions because 3 is the highest degree. For number 3, there are going to be 3 solutions because 3 is the highest degree. And for number 4, the highest degree I see is 4, so there would be 4 solutions. Oh yeah, does that ring a bell? All right, good. Oh, my pen's not working very well here. So it says, write a polynomial function of least degree with integral coefficients that has the given zeros. So these are zeros. We need to then put that into factored form. Oopsie daisy. Well, now the pen's working. That's good. So I guess I'm going to just do a quick example over here. Let's pretend that we were supposed to find the zeros of this polynomial right here. Well, we'd factor it. We're looking for numbers that multiply to negative 15 and add to 2, so we'd say it's positive 5 and negative 3. So we'd put that into factored form. Oops, there's an equals 0 there. So we'd say one solution is x equals negative 5 and one solution is x equals positive 3. Ooh, positive 3 because 3 minus 3 is 0. So now they're telling us that these are zeros. And so, by the way, folks, another phrase for solution here, again, these are our zeros. Zeros. So now they told us the zeros. What we're going to do is go backwards. We're going to go from the zeros to factored form. And once we find the factored form, we're going to take that and multiply it together to get our standard form. So it's in function form or standard form. So if negative 2 is a factor, that came from, oh, I misspoke. If negative 2 is a 0, like negative 5 was a 0, what's the factor that negative 5 came from? Negative 5 came from the factor x plus 5. So if negative 2 is a 0, it came from the factor x plus 2, right? Once you say, hey, if you saw this, you'd say, hey, negative 2 is a 0, is a solution. Don't let the eyes confuse you here, folks. If 3 was a 0, what's a factor? You'd say it's x minus 3. Well, now shove an I with it. And if negative 3 was a 0, what's the factor that it would come from? It would come from x plus 3. But now shove an I with it. Because, folks, negative 3i plus 3i is 0. And here, 3i minus 3i is 0. And negative 2 plus 2 is 0. Those are all zeros. So now we have things in factored form. Now we multiply them together to get them in standard form. So choose 2 of your factors and multiply them together. I'm going to actually multiply these 2 together first. Maybe perhaps some of you guys are scared of the i's. Let's just grab the bull by the horns. So x times x is x squared. X times 3i is 3ix. Now let's move on to the negative 3i. Negative 3i times x is negative 3ix. And negative 3i times 3i is negative 9i squared. So let's simplify this now. Oh, by the way, before we get too overzealous, let's not forget to bring down the x plus 2. So we're going to take x plus 2 times this stuff on the right, but let's simplify this. First of all, we can combine like terms. The positive 3ix and the negative 3ix are 0ix, so there's none of those. And then also, the negative 9i squared, remember that I squared equals negative 1. So this is really negative 9 times negative 1. That's positive 9. So really, it's positive 9. Keep that in mind. These two terms canceled out, so I have x squared plus 9. all of this stuff right here that I've highlighted really is x squared plus 9. So now we do some FOILing. We get x to the third, we get 9x, we get 2x squared, and we get 18. However, to write this in standard form, realize that these two terms need to get switched around. The x squared should come first before the 9x. So we have 2x squared and then 9x plus 18. Of course, I didn't say it, but there's the x to the third in front, right? Dang, that was kind of fun, huh? A little bit? Yes, I'm glad you agree. Alrighty. So let's try number 6. Let me grab this stuff, group it, and shrink it. Because that example that I did on the right, I think is the foundation of how we move forward with this stuff. I think it simplifies things. Alright, well that's not good. So number 6, we've got -3 and -I as zeros. So here's my zeros. Now I figure out what the factors are. If -5 was a 0, the factor it came from was x plus 5. So if -3 is a 0, it comes from x plus 3. If I see this factor, I'm like, oh, -3 is a 0 or a solution there. And now this was an I, right? Yeah, -I. Doesn't look like an I to me. There. All right, so if -I is a 0, that comes from what? X plus I. Because -I plus I is 0I, is 0. All right, so now let's FOIL this together. So we get x squared, ix, 3x, and 3I. And that, folks, we can't simplify anymore. So there we are. All right, here's my zeros. So zeros, now put it into factored form. So if 1, 0 is 3, that came from the factor x minus 3. And if -4 is a factor, that came, if -4 is a 0, that came from the factor x plus 4. And if 5 is a 0, that came from the factor x minus 5. There we are. Essentially, when you put it into factored form, your signs are going to be opposite. The positive makes a negative in here, the negative makes a positive in there, the positive makes a negative in there. So now let's FOIL. I'm going to just FOIL these first two binomials together first. Actually, you know what? I actually like going there first. I don't know why. There actually is something in my brain that I think in the long term is going to make this easier if you start over there. But let's not, whatever. -5x plus 4x minus 20. Combine like terms, please. Please combine like terms, because I'm going to have to multiply all of this by x minus 3. And if I can simplify and reduce the number of multiplications that I have to do, that's good. So -5x plus 4x is -1x. So now we distribute the x to everything, and then we'll distribute the -3 to everything. When you multiply by a negative, make sure you flip the sign of everything. So here, x times x squared is x to the third, x times -x is -x squared, x times -20 is -20x. On the bottom, here's what I'm meaning. -3 times x squared is -3x squared. But now I have a -3 times a -x. That's going to be a positive 3x. And a -3 times a -20 gives a product that is positive. Oh, not 20 though, 60. Hello. Now we combine like terms. Well, this x to the third is all alone. The x squared gets combined with that x squared, so we have -4x squared. The x's become -17x, and there's a positive 60. Good. Last one. So if negative 4 is a 0, the factor it came from is x plus 4. If 0 is a 0, that means it came from, I'm going to write this down, folks, but we're going to fix this. X minus 0 or x plus 0, it doesn't really matter because 0 plus 0 is 0. But this factor is going to get changed in a second. And then if it's positive 5 is 0, that came from x minus 5. So this looks funny, folks. And I'm going to write this, I'm going to write more than I need to here. And in the future, maybe you can just take this lesson and be like, oh, all right, I know how it should look like the quickest way. X plus 0 or x minus 0 is silly. It's just x. And then this x, I'm going to shove out in front because you realize how we factor out x's sometimes? That's what happened. So we have an x out in front, and then I'm going to write down x plus 4 times x minus 5. And I'm going to start on the right again. It just systematically seems to work better, I think. But you could start and multiply the x to the x and the positive 4. That's fine. So we get x squared minus 5x plus 4x minus 20. Very similar. I guess a lot of our zeros were similar. 2 of our zeros were similar. So right now, that's why that's ringing a bell. And then we have this x out in front. But do not distribute the x into that polynomial yet until you combine like terms. All right, there we go. So now we distribute it in. So we get, ooh, it's a bad rainbow. So we get x to the third minus x squared minus 20x. Boom. Huh? Not so bad. This is hopefully kind of making a full picture here. We're just doing the process that we've been doing, finding the zeros, but going backwards. They gave us the zeros, so we find the polynomial. Our answer is the polynomial.